We are very excited to be presenting our research at the International Sustainability Transitions Conference online. Today, we're presenting our research about the diffusion of multiple demand-side low-carbon innovations in a 1.5-degree energy transition. I am Christina Hoyka from York University, and my co-authors are Dr. Runa Das from Royal Roads University, Dr. Jenny Liu from TU Delft, Susan Wise from York University.
Hi.
Maria Louise McMaster from York University.
Hi there.
And Yushu Zhao from York University.
Hi.
This research has been funded by the Social Science and Humanities Research Council of Canada Insight Development Grant, as well as from the Faculty of Environmental Studies at York University and the Smart Prosperity Institute. And here's the outline of our research talk. And I'm going to dive right in to the topic of our research. The focus of this presentation is to tell you about how we identified a range of innovations and developed a conceptual framework for coding of innovations and the development of a statistical model. The research question that we are interested in answering is how and to what extent do low carbon innovations contribute to system change and sustainable energy transitions? And we were focusing on how do we identify a range of innovations in a geographic area, and what are the range and combination of factors that influence low carbon innovation diffusion to energy users. So our focus was on innovations that were being shared with energy users and how they were being taken up. The problem stems from concepts of carbon lock-in, that persistent behaviors have co-evolved into lock-in with technology, land uses, and institutions, and that this is the path dependency of complex systems of existing technologies, institutions, and behavioral norms that act to constrain the rate and magnitude of carbon emissions reductions. So we're interested in the idea that we know that we need to develop and diffuse the full potential of demand-side innovations in order to remain within 1.5 degrees Celsius, and that we need to accelerate our responses. And this requires not singular innovations, but clusters of low carbon innovations. This shift towards energy users engaging in multiple innovations is seen in many visions of low carbon transitions, where energy users need to be actively engaged with new transactional arrangements, new governance structures, and become producers, owners, and citizens of energy. However, innovation diffusion frameworks tend to focus on singular innovations, and they also tend to focus on hardware rather than on configurations and optimization. We know that people will choose to engage with new options or not, and this is an area where Wolsink has said social science researchers should focus their investigations. And what we've found is that there are very few studies that investigate the diffusion of multiple innovations. And this is a gap that we'd like to fill. So our first step in this was to identify a range of innovations in a geographic area. And we did this by using the Energy Technology Innovation System.
So the Energy Technology Innovation System is an approach to understanding the energy innovation system process, and it incorporates a comprehensive perspective of the production, distribution, and consumption of energy through the lens of technology. And so the ETIS, it determines the availability and efficiency and cost of the energy supply and demand services, as well as the social and environmental outcomes. And the four key dimensions of the ETIS process are knowledge, actors and institutions, resources, and then finally the adoption and use. And these dimensions comprise the framework with which the energy technology innovations are examined as they move through this innovation system. And the ETIS generally occurs in 5 consecutive steps. The first is research, then development, demonstration, market formation, and finally diffusion. And I'll pass it back to Christina to talk about the methodology.
The focus of the study was in Ontario, particularly due to proximity, since we're located in Ontario, but also because of significant policy shifts of energy deregulation to hybrid markets that's been occurring since the 1990s. A strong, well, maybe not strong, a scheme for decarbonization from 2003 to 2018, and as well as innovation policies from 2008 to 2018. And Ontario was also a very early mover in smart meter or advanced meter rollout. And what we did was we identified 4 policy domains across the ETIS. These policy domains were energy policy, climate change policies and action plans, industrial and science technology innovation policy, as well as social enterprise and innovation policy. And we looked for actors and organizations and networks across these policy domains, and we examined them and looked for innovations meant for energy users. And we did this using 3 main methods. So one was desk research across the ETIS and the 4 policy domains. And we found 32 innovations for energy end users. We also ran a survey of stakeholders across the ETIS and the policy domains. And this included a chain link component of the survey. And we found 90 innovations that way. And we ran a second survey of the providers of the innovations using both a chain link and networks. And so overall, we identified 132 innovations, 92 were active, and 40 were discontinued. This is very hard to see, so I'm not going to go into it in detail, but the first stage of the research using desk research was to identify innovations and also to prepare for the coding that we would do in later stages. So we identified implementation policies across the 4 policy domains, the stakeholders across the 4 policy domains, and the activities and programs, as well as the demand side innovations that were identified by those policies, stakeholders, and activities and programs across the 4 policy domains. And as you can see, we developed a very rich data set. Overall, we found 32 innovations using desk research, most of which were discontinued. And I'll pass it over to.
The stage 2 is to identify the stakeholders to survey. The table on the left shows the individuals we identified across the 4 policy domains. There is a total of 475 individuals conducted in survey 1. 94 of them completed the survey. The table on the right shows the individuals we contact across different types of stakeholders. 475 is the exact number of individuals we contact in the survey, but not the sum of contacted individuals of each type, because the type of stakeholders is not exclusive to each other. Some individuals identify themselves as more than one type of stakeholders, which makes the sum of contacted individuals of each type larger than the exact number of individuals we contacted in the survey 1. For survey 2, 90 individuals were contacted. 17 of them completed the survey. As we can see from the table on the right, nonprofits are more actively participate in the survey. I will pass to Lu to talk about surveys to identify low carbon innovations.
Thanks, Yishu. So as Yishu mentioned, in survey 1, we contacted 475 individuals. Of those 475, 135 survey responses were received, and 94 participants completed survey 1. From those surveys, from survey 1, 119 innovations were identified. However, 14 of those innovations were outside the scope of our analysis. And 8 of those were not yet an innovation, so they were ideas for an innovation, but not currently an innovation. And 7 of those 119 innovations were it had insufficient information provided by the respondent to identify the innovation fully. So in total, we had from survey 1, 90 innovations that were identified and that were relevant to our analysis, and 69 of those were active and 21 were discontinued. And then for survey 2, we received 17 completed surveys, and from those surveys, 7 of the responses described innovations that had previously been identified in survey 1, and then 10 responses identified new innovations. So in total, survey 2 identified 10 additional innovations, 9 of those which were active and 1 which was discontinued. Next slide, please. Great. So in our surveys and through the research, we were specifically looking for innovations for energy users that contribute to energy system change and to decarbonization. And so a demand-side low-carbon innovation is a product or service that will reduce or remove carbon emissions at the user stage, at the end-use stage of the energy system. And some examples of these are smart metering or demand response and distributed generation. And the aims of the innovations are presented in the left column of this table. And the aim of the innovation is the purpose or the focus of the innovation, such as energy efficiency or renewable energy. And so many of the innovations that did end up having more than one aim, which is why the number of innovations presented in this table does exceed 132. Next slide.
The next stage of the research was to code the innovations themselves for their characteristics. And we were interested in the questions: what are the range and combination of factors that influence low carbon innovation diffusion to energy users? And we were also interested in understanding how and to what extent do low carbon innovations contribute to system change and sustainable energy transitions.
So our research is inspired by a statistic model development by Clausen and Fichter, which undertook a comprehensive and detailed cross-sector analysis of the factors that influence the diffusion of environmental products and service innovations in Germany. Based on a systematic review of diffusion of innovation literature, Clausen and Fichter identified 22 comprehensive factors that have the potential to influence the diffusion of environment innovations across 6 fields of influence: product-related factors, adopter-related factors, supplier-related factors, sector-related factors, government-related factors, and path-related factors. These 22 factors and 6 fields of influence provide a holistic and systematic set of variables and scales that can be used for empirical investigations. Clausen and Fichter developed a statistic model in which these 22 factors were coded for each environmental product and service innovation to determine the degree to which they facilitate or inhibit environmental innovation diffusion. I will pass to Liu to talk about the model variables.
So our research model applies elements of the Clausen and Fichter 2019 model, but it differs significantly in 3 key respects. The first is that this research model expands beyond the diffusion dynamics variable to account for the influence on pro-environmental behaviors and the capacity to create system innovation. The second difference is that this analysis looks specifically at demand-side low-carbon innovations available to energy users. So it is energy sector specific. And the third difference is that this analysis focuses specifically on the disruptive potential of the innovations on the established socio-technical system. And our statistical model contains both dependent and independent variables. An independent variable is a system variable with a given value that does not depend on any other variable and acts as a controlled input to the model. A dependent variable, on the other hand, is a system variable with a value that directly depends on the model's independent variables and is a controlled output of the model. And our model, the statistical model developed by this research team, contains 4 dependent variables. The first is dissemination rate, the next is system innovation, followed by pro-environmental behavior, and finally energy justice. And I will pass it back to Yushu to discuss the dissemination rate dependent variable.
Thanks, Liv. The dissemination rate measures the degree to which an innovation has diffused into a certain population, which is an important dependent variable in cause and effect study. The formula to calculate dissemination rate is that the number of innovations currently in use to be divided by the reference population. The reference population is the sum of different types of users of this innovation. Type of innovations we assessed here include programs, policies, products, projects, and services offered to energy users in Ontario that have the potential to make an important contribution to a low-carbon energy transition. The uptake data and the information of the type of users were collected through desk research, Survey 1 and Survey 2. The population statistics was collected through Statistic Canada, OEB, and etc. Information about the year is collected through desk research and Survey 1. I will pass to Lou to talk about another dependent variable, system innovation.
So the system innovation dependent variable measures the potential for an innovation to contribute to socio-technical regime change. For this dependent variable, we created a template scale to evaluate an innovation's level of regime disruption or reinforcement potential. And this is presented in the table. This scale established the criteria for analyzing the relationship between the type of innovation and how the different elements of the system are influenced. Each innovation in the dataset was evaluated based on this overarching criteria, assessing an innovation's potential to create system disruption or to reinforce the incumbent regime. The reason for this step was to ensure that the model variables were reliable and consistent and supported by the literature. Following the development of this template scale, a range of 8 independent variables that influence system innovation were selected based on the relevant literature. And these selected variables include fossil fuel regime change, decentralization regime change, democratization, policy for scale-up through economic instruments, policy for scale-up through regulation, policy for scale-up through knowledge creation and diffusion, legitimacy through positive discourse framing, and finally, legitimacy through actors. Yushu will now speak to our independent variable 6, policy for scale-up through economic instruments.
I will use a policy for scale-up through economic instruments as an example to describe how we create the scale tables for these 8 independent variables of system innovations and explain how we code this independent variable. There are 3 types of policy instruments that are assessed in our study. Economic instrument is one of them. Economic instruments refer to economic incentives or cost internalization, such as user fees to internalize externalities and price goods and services. Technology-specific economic instrument is necessary to support these disruptive innovations from their early development while market introduction to the critical diffusion stages. The coding scale table for this independent variable is based on the previous scale table that Lou mentioned. We created for scale of disruption or regime reinforcement. That one was used as an overarching criteria to ensure the reliability and consistency of the whole coding system. So this scale or coding scale for this independent variable is also 5-point scales from -2 to +2. To code this independent variable, we will use the innovation as keywords and then go through a reference table that summarized all the government policies and reports to identify whether there are relevant economic policy instruments. And then we will retrieve the original documents of these policies and reports to make a final decision according to the definition and examples that are listed in the scale table. Through analyzing these resources, the economic instruments were identified and then coded. I will pass to Lu to talk about another independent variable, the legitimacy through actors with agency.
Yeah, so as Yusha mentioned, and was mentioned previously, one of the factors that influences an innovation's potential to create system innovation is also legitimacy. And legitimacy is built in part through the presence of actors with agency that support the diffusion of the innovation across multiple scales. This means that having strong networks of actors, which can include individuals, organizations, or institutions, working to support the innovations within and across the policy domains is a signal for legitimacy. And so this independent variable codes specifically for the types of actors supporting the scale up of the innovations. In order for an innovation to be disruptive, it required the presence of niche level, intermediary, and regime level actors supporting and advocating for the niche scale up within a single policy domain, and as well as the presence of regime level actors supporting the innovation across policy domains. And it was the presence of both of these conditions that influences the innovation's disruptive potential. This innovation was, this innovation variable was coded by analyzing a combination of survey responses, provincial, municipal, and federal government policies and reports, the organizations that offer the innovation's websites, and any other documents or reports produced by the organization that discuss the innovation, as well as media releases. And through analyzing these resources, the relevant actors were identified and then coded for. I will now pass it off to Sue to describe our energy justice dependent variable.
Thanks, Lou. We've also developed coding to investigate the relationship between the innovations in our data set and justice. To do so, we drew from an area of literature that's emerged over the last decade, energy justice, which shares normative ideals with longer-running social movements like environmental justice, but has principally been developed as a more focused academic term and analytical tool aimed at framing and understanding critical energy issues. Broadly, it concerns the intersection of justice, equity, and fairness with energy activities. So our coding employed 4 indicators for the justice variable. These include availability, affordability, due process, and access to information. We consider the distribution of these indicators across 13 types of energy users. For example, when assessing the affordability of an innovation, we considered whether or not the innovation improves affordability for each type of energy user. For example, households, where we separated out homeowners, renters, and low-income households, communities, nonprofit organizations, and businesses. So this allows us to investigate how the benefits associated with each innovation in the system are distributed across society. And by doing so, we can also see who is getting left behind. Lastly, unlike our other scale variables in this project, the justice variable employs binary coding due to the lack of available research to support a more scaled approach for each type of energy user. As such, for each, the indicators were coded as presence or lack of presence of justice. Next slide, please. So this research is building on Clausen and Fichter's model. However, while theirs is focused on the diffusion of innovations that favor compatibility with the incumbent system, ours focuses specifically on the disruptive potential of innovations on the established socio-technical system. We will run statistical analyses through regression modeling in order to identify the key factors that are significant across diffusion cases. We'll be publishing on methodology and results across the 4 dependent variables of dissemination rate, system innovation, pro-environmental behavior, and energy justice. On to the final slide, please. So that concludes our presentation. Thank you very much for your time today. We would love to hear your thoughts about our research. So if you'd like to touch base, here's the ways to contact our labs. We very much hope you enjoy the rest of the conference.